Section 3.6, proportional and non-proportional relationships. Our essential question is, how do you identify if a graph or equation is proportional? Well, our new vocab words are proportional and non-proportional. When you're looking at a graph, it is proportional if it is a line through the origin. And it is non-proportional if it is not a line through the origin. In the equation from our lesson yesterday, or from day 1 of 3.6, you may remember that if a line goes through the origin, its equation is going to look like this. There is not going to be an intercept over here because it goes through 0, 0. The intercept is 0, so you don't have to write it. So what we could say is that it's f of x equals mx plus b when b equals 0. So it won't even be written. And on the other one, for non-proportional, it's when b is not equal to 0. So when b is something else, it's going to be a line that does not go through the origin. So maybe instead of saying not a line through the origin, we should say a line that does not go through the origin. There, that sounds better. So a line through the origin and a line that does not go through the origin. Now you're going to see some tables or maybe even some word problems in this section. This problem says, this table shows the number of miles traveled for each hour driven. So we've got a table with hours 1, 2, 3, and 4, and then miles 50, 100, 150, 200. There are 4 steps here. It says graph the data, write an equation to describe the relationship, and then answer this question on part C. Find the number of miles driven in 8 hours, and is this function proportional? Well, to graph the data, I know that my hours are going to have to go on the x-axis because they're independent. And then the miles driven is going to go on the y-axis because the miles depend on how many hours we've driven. So 50, 100, 150, 200. Okay, you may notice just by looking at this table that for each hour that's driven, for each hour, for each 1 hour, the number of miles is increasing 50. So if I draw a line to represent this situation, it most certainly goes through the origin, 0, 0. If I went backwards in my table over here to 0, and I went back 50, I would also be at 0. So I have my graph now for part A, and I already know part D that it's proportional because it's a line through the origin, 0, 0. Now write an equation for this relationship. For part B, my equation, well, the rate of change or the slope of this line, it's going up 50 over 1. So rising 50, and the run is 1. So my slope or rate of change is 50, and then I put in my x. I don't have an intercept because it goes through 0, 0. Now, let's answer the question. Find the number of miles driven in 8 hours. Well, if this pattern continues, because we've got a line here, if this pattern continues, I can plug in 8 for x, because x represents the number of hours, and 50 times 8 would be 400 miles. So my x-axis, my variable x represents the number of hours. So right here on the x-axis we have hours, so I could plug in that 8 for x and solve my equation. Next example, just like the last one, number of t-shirts and the cost. So I'm going to put the number of t-shirts on the x-axis because the number of t-shirts is independent. You get to decide how many t-shirts you're going to buy. Then the cost is going to depend on how many t-shirts you're buying. Now, you may notice that on my x-axis it makes sense 0, 2, 4, 6, 8. But I'm a little concerned on the y-axis because if I go from 0 to 20, I wouldn't have 30 next. So I am actually going to have to start with 10 because it looks like we're going by tens before I graph my data. So 2 t-shirts cost $20. 4 are $30. 6 are $40. And 8 are $50. So if I draw this line, you should notice that it does not go through the origin. It instead hits the y-axis at 10. So we've got our graph. Part B, write an equation. Well, the slope of my line, it's going up 10 and over 2. 10 over 2. 10 divided by 2 is 5. So f of x equals 5x, because my rate of change is 5, 10 over 2. And then plus my intercept, which was 10 right here. Okay, now let's find the cost for 20 t-shirts. So if I plug in 20, 5 times 20 plus 10. That would be 100 plus 10, or $110 for 20 t-shirts. And then part D, is it proportional? No, because my graph did not go through 0, 0. So now we've seen one of each type. One of each type where we're looking at a table and answering some questions about it. Here's a third example like that. You may be able to tell from the table, it's going by ones. If I go back 1, I'd be at 0. Going by 3s. If I go back 3, I'm at 0. So you may be able to tell now on this one that this is going to be proportional. I've got number of packages. We're talking about packages, CDs per package. So the number of packages and then the number of CDs. The number of CDs depends on how many packages, because we're talking about CDs that are in each package shipped by a company. Okay? This should be very similar to the first problem that we saw. So my line definitely goes through 0, 0. My equation here. My rise is 3, run is 1. So 3 over 1 is 3 for the slope of my line. So f of x equals 3x. I don't have an intercept because it goes through 0, 0. Well, I shouldn't say I don't have an intercept. I've got one, but it's a 0. So I don't have to write it in my equation. Now, 8 packages. Packages are on the x-axis, so I can substitute 8. If I had 8 packages, there would be 24 CDs. And last but not least, is it proportional? Yes, because it goes through 0, 0, and it's a line. Okay, now the second part of our lesson is partially review. So we are going to review writing an equation for our line in function notation, and then we're going to say if it's proportional. So to write my equation, hopefully you recall we need 2 points on the line, and they need to be right where the grid lines intersect. Rise over run, rise 1, run 2. So my slope or rate of change is 1 over 2, 1/2. This intercept, where the graph crosses the y-axis, is at +2, so +2. That's the equation for my line. Now determine if it's proportional or non-proportional. Well, it's a line, but it doesn't go through 0, 0, so it's non-proportional. Next one. 2 points to find the slope. I always go with the intercept for one of them, if I can. And then move over to the right to find the next good point to use. So my slope on this problem, rise, I'm going to have to go down 1, and then run 3. So f of x equals -1 over 3x, -1/3 is my slope. My intercept, this line goes through the y-axis at 0, so I don't have to write my intercept. So that means if it's 0, a line through the origin, it's proportional. Next one. Intercept is right here. Another point on this one that looks good. You know, the point up at the top is, I'm not really sure about, so I'm going to go down. This is the spot that looks really good to me. Okay, so now I'm going to have to start at the point on the left, rise. 5, run 3, 5/3. So f of x equals 5/3 x. And then my intercept, where it goes through the axis, here's the origin, so it's up 3. So +3. And it does not go through the origin, so it's non-proportional. Non-proportional. Next example. 2 good points to use, my intercept point and this point right here. So start at the point on the left, rise, down 3, over 2 to the right. So f of x equals -3 over 2x, and then my intercept point is right here at 4, so +4. +4. It's a line, but it does not go through the origin again, so non-proportional. I think this is our last example. My intercept, and then one more point to the right, and I'm going to go all the way down here to the bottom. This slope, starting at the point on the left, I'm going to have to go down 5, so -5. And then over 3 for the run to the right. So f of x equals -5/3 x. And then this line does go through the origin. So I don't write an intercept because my intercept is 0, and that makes this relationship proportional. I think you're ready to write your summary. And here are your homework problems. It doesn't look like very much, but remember, some of them are like those first ones where they have multiple parts to them with the tables. So please don't skip any problems.